students, welcome you all to our brilliant channel Maths Nation. Dear students, if you have not subscribed Maths Nation, kindly subscribe it now and press the bell icon to get the notification of the upcoming videos. So let us start the today's lecture of class 10 chapter polynomial. Today we discussed about division algorithms. This is polynomial. The chapter is polynomial. Today we discussed about division algorithm of polynomials. In your previous class, you know the division algorithm of integers. The same formula is also applicable for the division algorithm of the polynomials. In division algorithm of the integers, you know dividend is equal to divisor into quotient plus remainder, means capital D is equal to dividend is equal to divisor into quotient plus remainder. This is capital D is called the dividend, this small d is called the divisor, this is quotient and this is remainder. When the number, the dividend is completely divisible by the divisor, then in this case we get the 0 remainder. But when the number is not completely divisible, in this case we get the remainder. For example, when you divide 25 with 4, is 25 completely divisible by 4? No, because when you divide you get 6 into 4 plus 1, where 4 is the divisor, 6 is the quotient and 1 is the remainder. But when you divide 35 divided by 7, this is equal to 7 into 5 plus 0. In this case 7 is the divisor and 5 is the quotient and remainder is 0. When you get the remainder is 0, this means the number, the dividend is completely divisible by the divisor. Then when you get remainder, this means the dividend is not completely divisible by the divisor. In the same formula, the same logic is also applicable for the division algorithm of the polynomials. Suppose here the fx is the polynomial and qx is the gx is the divisor, fx is the dividend, gx is the divisor and qx is equal to quotient, qx the quotient and rx is equal to remainder. Then here fx is equal to gx into qx plus rx. In the same way, when the fx is completely divisible by gx, means when gx is a factor of fx, in this case you get rx is equal to 0. When the remainder is equal to 0, this means gx is a factor of fx. Suppose take some examples, take one examples for better understanding. Students, I have already told you only knowing formula is not sufficient for maths. When you practice variety of questions, then which will be helpful for your exams. Then as I have told you, when you practice variety of questions, then the questions which will be asked in your exam paper is not a challenge for you. And I have already told you the 2.0 series is the next level series in which I have discussed the theory to the root level and practice vigorous problems. If students, you may practice any books, you please do your worksheets and ask me your doubt. I am ever ready to clear your all doubts. Here take some examples. Here the question is given, fx is given here, fx is equal to 14x cube, fx is equal to 14x cube minus 5x square plus 9x minus 1. Then here the gx, the divisor is given here 2x minus 1. Then find the quotient and remainder. Then here when you find, if we get the remainder is 0, then this shows that 2x minus 1 is a factor of 14x cube minus 5x square plus 9x minus 1. This means gx is a factor of fx. Now let us do this. Use the long divisions methods for it. Then students, I keep it here. If I use the next page, then this will be difficult for you to get the questions. Hence I keep the questions in a corner and do the solutions. Let us solve this. This here fx is given here 14x cube minus 5x square plus 9x minus 1. Gx is given here 2x minus 1. Then 14x cube, to get 14x cube in 2x, you have to multiply 7x square. Then 7x square into 2x means this is 14x cube. 7x square minus 1 is equal to minus 7x square, then minus plus, then here minus 5x square plus 7x square means this is 2x square plus 9x minus 1. Then from 2x to get 2x square, we have to multiply with x. X into 2x is equal to 2x square. X into minus 1 is minus x. Then here when we subtract, we get this is 9x plus x, 10x minus 1. Then from 2x and here this is 10x, you have to multiply this with 5. Then 5 2 ja 10x. 5 into minus 1 is equal to minus 5. Then when you subtract, you get this is 10x cancel, then this is 4. Then next we cannot solve, then this is the remainder. What is 4 here? 4 is the remainder here. Then what is 7x square plus x plus 5? This is the quotient. This is the divisor, this is dividend. Then here this is, here gx is equal to 2x minus 1, qx quotient is equal to 7x square plus x plus 5, and the remainder r is equal to 5. Then this can be written as fx is equal to gx into qx. This means 2x minus 1 into 7x square plus x plus 5 in plus remainder is 4 here, remainder is 4 plus 4. This is the equations revision algorithm of the given questions. Here in this questions, the question is asked to find out the quotient and the remainder. By solving the questions, we come to the conclusion that we get the quotient is 7x square plus x plus 5 and the remainder is 4. You students, please do your worksheets and ask me your doubt. I am ever ready to clear your all doubts. Please students, drop your doubt in my comment box. I am very happy to clear your all doubts. Now let us solve the another questions here. Here another question says that, another example says that divide the polynomial. Here the fx is given here. Here the fx is given 6x cube plus 11x square minus 39x minus 65. fx is this, and here gx is equal to x square minus 1 plus x. Very important thing when you divide, before doing the division, it is very important to keep the fx and gx in ascending order, in descending order of their powers, of the power of the variables. Here f(x) is equal to 6x cube plus 11x square minus 39x minus 65. This means here the power of the variables is in the already in the descending order. But look at gx here. Here the gx, the divisor here, this is x square minus 1 plus x. Here the exponents of the variable is not in descending order, it is not in systematic order. To at first write it in systematic or descending order. Here at first we write x square, then plus x, then minus 1, then do the divisions. Divide f(x) divided by gx, then here the f(x) is given 6x cube plus 11x square minus 39x minus 65, and gx is given x square plus x minus 1. Then at first to get 6x cube, then at first we write this is 6x. When 6x is multiplied with x square, we get this is 6x cube. 6x into x is plus 6x square. 6x minus 1 is minus 6x. Then do the subtractions. When we subtract, you know the sign will be opposites. Then 11x square minus 6x square, this is 5x square, minus 39x plus 6x is minus 33x minus 65. Then next will be plus 5. 5 when multiply with x square, we get this is 5x square. Then 5 into x is minus is plus 5x. 5 into minus 1 is minus 5. Then when you subtract, you get this is minus 33x minus 5 means minus 38x minus 65 plus 5, this is minus 60. Can you do next? No. Here we cannot divide more. Long. Then this is the remainder. This is quotient here. Here qx is equal to 6x plus 5 and remainder rx is equal to minus 38x minus 60. Then this is the remainder and this is the questions. Here in this questions, the question is asked to find out the quotient and remainder. Then by solving the divisions, we get here the quotient is 6x plus 5 and the remainder is minus 38x minus 60. As I have told you, please students say me, when we get the remainder is 0, then what does this means? When the remainder is 0, this shows that if the division algorithm shows f(x) is equal to qx into gx plus rx, then when the rx part is 0, this shows that f(x) is equal to gx into qx. This shows that gx divisor is the factor of fx, This means fx is completely divisible by the given divisor means gx. Fx is completely divided by gx. This means gx is a factor of fx. Now let us discuss some more examples. I have already told you, when you practice variety of questions, then you get confident, you will be confident to face any questions which will be asked in your exam paper. Then let us solve Example 3. Here the example 3 says that divide the polynomial. Here the polynomial ux is given. This is 9x fourth minus 4x square plus 4, and here gx is given, bx is given. This is 3x square plus x minus 1, and here also find the quotient and remainder, the same thing. At first a remainder, then at first do the divisions, try to do the divisions. Ux is equal to Vx into Qx plus Rx. Here Qx is the quotient and Rx is the remainder. Then do the sum, then do the solutions. Here the Ux is, look at here, at first very important thing, verify the given dividend and the divisors. Dividend and divisors in this polynomial, the exponents of the variables should be in descending order. Here in ux, look at ux is in descending order or not. Exponents of the variables, this is x fourth, this is x square, then this is x to the power 0, and here x square, x to the power 1, x to the power 0. This means ux and vx both are in descending order of the exponents of the variables. Then let us do the solutions. Let us solve the questions. 9x fourth minus 4x square plus 4 is divided by 3x square plus x minus 1. To get 9x fourth from 3x square, this is 3x square into x, this is 9x fourth. When you multiply 3x square with 3x square, you get 9x fourth. Then 3x square into x, you get, this is plus 3x to the power q, 3x square minus 1, then this is minus 3x square. Then when you subtract this cancel, then where you get minus 3x cube minus 4x square plus 3x square, this is minus x square plus 4. Then from 3x square to get 3x cube, here we have to multiply this with x minus x minus x. When minus x multiply with 3x square, we get, this is minus 3x cube minus x into x, this is minus x square minus x into minus 1, this is plus x. Then here when the sign is changed, this cancel, this cancel, then we get, this is minus x plus 4. Here by solving this is the quotient and this is the remainder. Then here the question is asked to find the quotient and remainder of the given polynomial when the polynomial ux is divided by vx. Here ux is the dividend and vx is the divisor. Then by solving this we get that qx is equal to, the quotient is equal to 3x square minus x and the remainder Rx is equal to minus x plus 4. Then this is the answer of the given questions. The given question is asked to find the quotient and remainder. Please students recall the division algorithm of integers. The same division algorithm is also applicable for polynomials. Here another question says that the same thing, when you get the remainder 0, the remainder 0 means qx is the factor of fx. Now let us discuss some more examples. Here another example says that here fx is given. Here in this example 4, fx is given, fx is equal to 30x fourth plus 11x cube minus 82x square minus 12x plus 48. Then this is f(x), and here the gx is given is equal to 3x square plus 2x minus 4. Then here also we have to find out the quotient and remainder. Now let us solve the questions. Now let us solve the question solution. Here when you divide f(x) by gx, this means 30x fourth plus the very important thing, when you do the solutions, at first look at here whether the exponents of the dividend and the divisors are in descending order or not. If not, at first keep it in descending order. Here in f(x), this is the, look at the exponent of the variables. Here this is x4, then this is x cube, then this is, this is 82x square, this is minus 12x 48, then this is divisible, we should divide this with gx, which is 3x square plus 2x minus 4. Then when you divide 3x square with 30x fourth, this means 10x square. 10x square into 3x square we get, this is 30x fourth. 10x square into 2x is equal to 20x cube. 10x square minus 4 is equal to minus 40x square. Then when you subtract, then this we get 11x cube minus 20x cube, this means minus 9x cube, and minus 82x square plus 40x square, this is minus 42x square plus minus 12x plus 48. Then to get minus 9x cube from 3x square, we should multiply this with minus 3x. Minus 3x into 3x square, this is minus 9x cube, and minus 3x plus 2x, this is minus 6x, minus 3x minus 4, this is plus 12x. Then when you subtract, this is plus, then this is 6x square, then this is plus minus 12x, this is plus 12x, this is minus, this cancel, minus 42x square plus 6x square, this is minus 36x square, and minus 12x minus 24x plus 48. Then from 3x square to get minus 36x square, we should multiply this with minus 12. Minus 12 into 3x square, this is minus 36x square, minus 12 into 2 is equal to minus 24x, then minus 12 minus 4, this is plus 48. When you subtract, then this cancels. At last here we get the remainder is 0. As I have told you, here the remainder is 0. Remainder is 0 means gx is a factor of fx. Gx is a factor of fx. This means fx is equal to 3x square plus 2x minus 4 into 10x square minus 3x minus 12. Here this is the factor gx, the divisor is the factor of the dividend when we get the remainder is 0. Here in this case we get the remainder is 0. This means gx is a factor of fx. Now let us solve some another types of questions. Please students, do your exercises. Here the question says that The same thing here, the fx is given, here the fx is given, the questions example 5. Here fx is given 2x fourth minus 3x cube minus 3x square. It is very important when you solve the questions, at first keep the exponents of the dividend and the divisors, both exponents should be kept, exponents of the variables should be kept in descending order. Here this is x fourth, x cube, x square, x minus 2. This means in the fx all the exponents of the variables are in descending order. Then the next gx is given here, here we have to show that, plus root 2 and minus root 2 should be zeros of the given polynomial fx. How can we prove that plus 2 root 2 and minus root 2 are the zeros of the polynomial? In which case we say that these are zeros of the polynomial. When the if f of root 2 is equal to 0, this means root 2 is the 0 of fx, and in the same way minus root 2, if f of minus root 2 is equal to 0, this shows that minus 2 root 2 is also 0 of the polynomial fx. But here we have proved in different way. This means if root 2 and minus 2 root 2 plus root 2 root 2 and minus 2 root 2 are zeros of the polynomial, this means x plus root 2 and x minus root 2 are the factors of the polynomial fx. This means x plus root 2 and x minus root 2 should be divisible by fx. This shows that when we multiply x plus root 2 into x minus root 2, we get this is a plus b and into a minus b. This means a square minus b square. This is x square minus 2. Root 2 whole square is 2. This is x square minus 2. If the polynomial fx is completely divisible by this polynomial, this shows that x square minus 2 is a factor of fx. If x square minus 2 is a factor of fx, when we get, how can we prove that x square minus 2 is the factor of fx? How? When the remainder is 0, when we divide fx by x square minus 2 and we get rx is equal to 0 or remainder is equal to 0. This shows that x square minus 2 is a factor of fx. Is a factor of fx. Am I right? If x square minus 2 is a factor of fx, this means x square minus 2 is equal to 0 or x is equal to plus or minus root 2. This means plus 2 root 2 and minus 2 root 2 are the factors of fx. Yes? Look at here. Now let us solve. Here the fx is given 2x fourth minus 3x cube minus 3x square plus 6x minus 2. Divide this with x square minus 2. Here our aim is to prove the remainder is 0. If the remainder is 0, this shows this is the factor of this. If this is the factor of this means fx is equal to qx into gx. This is gx, or by dividing we get qx, we get quotient. This means when in which case fx is 0. What is the 0? When x square minus 2 is equal to 0. When x square minus 2 is equal to 0, this shows that x is equal to plus 2 root 2 or minus 2 root 2. This means plus 2 root 2 and minus 2 root 2 are the zeros of the polynomial given. Let us prove. Here to get 2x fourth, we have to multiply with 2x square. 2x square into x square we get, this is 2x fourth, 2x square minus 2, this means minus 4x square, okay. Then minus, this is plus, cancel, this is minus 3x cube minus 3x square plus 4x square, this means plus x square plus 6x minus 2. From x square to get minus 3x cube, we have to multiply this with minus 3x. Minus 3x into x square, this is minus 3x cube minus 3x minus 2. This means this is plus 6x, then minus minus plus minus this cancel, then we get here this is x square minus 2. Then to get x square minus 2x square, multiply with 1, 1 into x square is x square, 1 into minus 2 is minus 2. Then by subtracting this we get this is 0. This means here we get, this is the main important, this is the main important part of the questions. Here you get the remainder is 0. The remainder is 0 means fx is equal to gx into qx, gx into qx. Keep it here and solve the questions. If I use next page, then this is difficult for you to understand. Keep it there and let us solve. Here you get, here gx is equal to x square minus 2 and qx quotient is equal to 2x square minus 3x plus 1. As the remainder is 0, this shows that fx is equal to gx into qx, means x square minus 2 into 2x square minus 3x plus 1. Then to find the zeros, means when fx is equal to 0, this shows that x square minus 2 into 2x square minus 3x plus 1 is equal to 0, which shows that x square minus 2 is equal to 0. This shows that x is equal to plus or minus root 2. This proves that plus or minus 2 root 2 are the zeros of the given polynomial fx. When the f of x is equal to 0, when x equal to plus 2 root 2 or minus 2 root 2. In these two cases, we get fx is equal to 0. This shows that plus 2 root 2 and minus 2 root 2 are the zeros of the polynomial. Here let us solve another questions. Here another question is given here. Another question is given here. If the two zeros of fx, here fx is given, fx is equal to x fourth minus 6x cube plus minus 26x square plus 130 plus 138x minus 35. Here fx is this and are to find the other zero. Here 1 0, 2 zeros of the polynomial is given. Here 2 zeros of the, here qx is given 2 plus or minus qx. Here the zeros of the 2 zeros of the polynomial, here 2 zeros of fx is given 2 plus or minus root 3. This means 1 0 qx is equal to x into x plus 2. Look at here qx is x minus 2 plus root 3 and x minus 2 minus 3 root 3. These are the zeros of the polynomial, means qx is equal to x into 2 plus x minus 2 plus 3 root 3, x minus 2 minus 3 root 3. Here we have to find out some other zeros, means this is equal to, we have to divide fx by, multiply this, we get this is equal to x minus 2. When we multiply this, when we open the bracket, this is x minus 2 minus root 3 into x minus 2 plus root 3. When we multiply this, we get this is x square minus 4x, x square minus 4x plus 1. Then here the qx is given here. When we multiply, when we divide fx by qx, we get the gx, then gx from, as these are the zeros of the polynomial, this means here the remainder is 0, keep it here, remainder is 0. By doing this we get the gx. Now let us solve here. Divide fx, here divide fx means fx is here, divide x fourth minus 6x cube minus 26x square plus 138x minus 35. When divide by x square minus 4x plus 1, we get the remainder is 0. By solving this, we get the remainder is 0 and the quotient is equal to x square minus 2x minus 35. If this is, by dividing this with this, we get the quotient this and remainder is 0. This means this is also a factor of this. If this is the factor of this shows that x square minus 2x minus 35 is equal to 0. Then use here middle factor factorizations. We get x square minus 7x plus 5x minus 35 is equal to 0. X into x minus 7 plus 5 into x minus 7 is equal to 0. Here x minus 7 into x plus 5 is equal to 0. This shows that x equal to 7 or x equal to minus 5. Here 7 or minus 5 are another two zeros of the polynomial fx. Here the question says that 2 plus or minus root 3 are the zeros of the polynomial fx. This means these are the zeros of the polynomial fx, means the x minus 2 plus root 3, x minus 2 minus 3 root 3 are the factors of the given polynomial fx. As these are the factors of the given polynomial, this means remainder is 0. When we divide this, we get the quotient is x square minus 2x, we get the quotient as x square minus 2x minus 35. As this is the quotient and remainder is 0, this means this is also another factor of fx. If this is the factor of fx, this means this qx is equal to 0. Then x square minus 2x minus 35 is equal to 0. By applying middle factor factorizations, by solving this, we get x minus 7 into x plus 5 is equal to 0. Then or x equal to 7 or x equal to minus 5. This means 7 or 7 and minus 5 are also another two zeros of the given polynomial fx. Okay. Thank you, students.